Let's look at this problem. A projectile thrown with a velocity u making angle theta with horizontal, as usual, same as the last problem we discussed in the last lecture. So we have to find the time after which velocity of the projectile is perpendicular to the initial velocity vector. So it's thrown in this way with a speed u and making angle theta with the ground with horizontal, and it travels like this. So at which point of time velocity of the projectile here, velocity of the projectile v is perpendicular to the velocity at which it is thrown u. I will show you the easiest of all methods. No method can be easier than this method. See, for this projectile, the acceleration is g downwards, g vector downwards. Okay, and as it is uniform acceleration motion, so we can write v is equal to u plus, so at, so a will be g vector into t. Now just what you have to do is draw a diagram. That's u, make it this a line, horizontal line, that is the vector u. I'll write the magnitude is also u. Okay, so this makes angle theta. Now this, so u plus gt, so we will use triangle law, u vector plus gt vector, u vector plus gt vector this way will make v vector. See, v vector is perpendicular to which one, this u. So that's vector gt, that's vector v, and see this was theta, so this angle is 90 degree. This angle is 90 degree. This one. So as this is theta, this is 90 minus theta, this is also theta. Okay. And if I just write about the magnitudes of the vectors, magnitude of this magnitude is actually u, right? Magnitude is u, length of this line u, length of this line gt, and length of this line is v. And see, this is a right angle triangle, so here you get gt sine theta is equal to u. See, just you have to use the triangle law of vector addition and the problem is solved. In most of the books and walkthrough problems, you will find it done by more longer approach than this, surely. See, so t, so therefore see gt sine theta is equal to u, this one, so therefore t equal to u divided by g sine theta. Now let's do some more problems on projectile motion that will get our concept clearer. Problem number 2 of this lecture is like this. Let me complete the diagram first. See, this u equal to 15 meter per second, this angle 37 degree. Okay, so this is the path of the projectile. Yeah, now this is a man so given p, this is point a, this is point b, this distance is given as 9 meter. Okay, the statement of the problem is that a ball hit by a batsman at angle 37 degree with speed this 15 meter per second, as shown in figure, as shown in figure. Okay, now the man standing at P should run at what minimum velocity so that he catches the ball and next thing is given like this. You assume that height of man is negligible. Comparison to maximum height, compared to height of projectile, compared to the maximum height of projectile. Okay, as it is given, so what can we do? So here g is equal to 10 meter per second square. Okay, so looks pretty simple that so it's actually when the ball was kicked or when the ball was hit, the man was here simultaneously. So that's t equal to 0 here, and the man also starts from here t equal to 0. Now this comes here at t equal to t, and the man also comes here at t equal to t simultaneously. So first you have to find the total time of flight of the projectile. Total time of flight. Okay, yeah. So what is the time of flight? Time of flight t equal to 2u sine 37 by g. So that's 2 into 15 into sine 37 is 3 by 5 by 10. Okay, so 5 3s are 15. It's okay now. 2u sine theta by g. Yes, so that's at 1.8 na. 3 are 9 to 18 by 10, 1.8. So that's 1.8 second. In 1.8 say, so the suppose the speed of the man is v. So v is a speed of the man. Then obviously v multiplied by 1.8 will give you 9. So therefore v equal to 9 divided by 1.8. This much meter per second, right? So what will you get here? 5 9 times this times 5 times 5, right? So that will cancel na? So that's comes out to 5 meter per second. Now we'll attend more. Okay, let's learn about a new thing. Then projectile thrown from a certain height. Okay, projectile thrown from a height. Now we will have one more video where we will show you how to solve problems on all these subtopics: projectile ground to ground, projectile thrown from a height, projectile thrown on the inclined plane. All these problems will show you in a different video, only dedicated for problem solving. Right now let's learn that projectile thrown from a certain height. So how to deal with this type of questions? So this is nothing new actually. So let this height be h. let this height be h, and projectile is thrown at a certain speed u, making angle theta with ground. And suppose you want to find out all these things, the time to reach ground. Okay, so let's make a statement out of this diagram. So a projectile thrown at speed u, making angle theta with horizontal from top of a tower of height h, from top of a tower of height h. Okay, find the time taken to reach ground. Time taken to reach ground. Also find distance of the point where it hits ground from foot of the tower, from foot of the tower. That means you have to find this distance d. This is the distance of the point where projectile hits ground from, this is the foot of the tower. Okay, so two things here. First you have to find out the height, and then this, sorry, not the height, the time taken to strike ground, and then this distance d. Here also the acceleration is g downwards. Now what was our thumb rule for solving problems? First, consider a coordinate system. As this is two-dimensional motion, first consider the x and the y axis, a pair of axes, and then accordingly, as these are all vector quantities, so you can write u, v, whatever as vectors. Okay, so I'll go for this point, origin, and this is the x axis, and I'll choose y axis as upwards. If you want, you can choose y axis downwards. That's up to you. The answer does not depend on your choice, right? It will strike at the same time. Whether you take y axis upward or downward, if you measure by a stopwatch as it's thrown from here, it will take same time. Does not depend on your choice. But to solve the problem, you have to make a choice. Else how will you make use of the equations of motion? Okay, so find, so that's the first one. Find time taken to reach ground. Also find the distance. Okay, let's find the time taken to reach ground. Okay, so here, so again you know that same thing, na? Repeating the same thing. Ux equal to u cos theta, uy equal to u sin theta. Then this ax equal to 0 and ay equal to minus g, as we have chosen y axis upward. So I'll go for this y equal to u sin theta t minus half gt square. So we will use here this equation. This is suitable for this case. To find out time, you will have to solve a quadratic for time. When it hits ground, the value of y is equal to minus h. Therefore minus h equal to u sin theta t minus half gt square. Okay, so half gt square minus u sin theta t plus h is equal to 0. So from here, from this equation, you will get a quadratic in t. Obviously you will have to consider the positive value of time. So that's minus b, we will use the Sridharacharya formula, plus, we'll use one of the roots, right, plus 1, b square, okay, minus 4ac, there it is, let's see, minus a, okay, plus becomes minus, is it, no, this should be a minus sign, right, this should be a minus sign here, right, let me check it again, minus h equal to u sin c, when it hits ground, y equal to minus h, u sin theta t minus half gt square, right, so half gt square minus minus, yeah, b square minus 4ac, so plus 2gh divided by 2a g, this is it, this is the time, okay, this is the time it takes to reach from this point to this point. You can put h equal to 0, so it becomes a ground to ground projectile, it becomes 2u sin theta by g. So that's one part of the problem solved, and the next part, also find the distance. The distance will it's a relatively simple one. Here we will use the equation of the range, y equal to x tan theta minus gx square by 2u square into 1 plus tan square theta. So here you put y as minus h, and so put y equal to minus h and solve for x. See, it will maybe a tedious job, but still okay. So this minus h equal to here equal to x tan theta minus gx square by 2u square 1 plus tan square theta. So solve for x, there will be two values. See, this is quite logical to have two values, because this is the coordinate system I have chosen, x and y. See, the equation of this parabola is throughout, na? The equation doesn't know that it follows this one part of the curve, so it's all along. So if you start if you substitute y as minus h, that means this minus y coordinate is minus h, you have two values of x coordinate. So the positive root is d, positive root is d, positive value of x is the solution to this problem. Or else you can do one thing also, for finding d, you will just put here easier one to find the d. See, what about the x coordinate? X coordinate becomes u cos theta into t, as we have found out t in part 1. So therefore d equal to u cos theta, and substitute d. This one, right? So you have, in part 1 we have found out the time it takes to reach ground, multiply the x component of velocity with it. Anyway, there is no acceleration in the x axis.